Let's start by solving a couple of questions what you have studied so far. All right. See what we are doing. We have to calculate the differential equation for the family of curves. Along with that, we have to eliminate the arbitrary constant. Now, what are the arbitrary constants? Let's look at the problems. Look at the first one. See here, A and B are the arbitrary constants, and you need to eliminate A and B and write the differential equation of that particular part. Now, you all know that it's a line, correct? X by A plus Y by B is equal to 1 is a line which cuts the x-axis at A and y-axis at B, right? Now, in this case, first what do we do? Differentiate. You'll get 1 by A plus y dash by B is equal to 0, or y dash by B is minus 1 by A, y dash is minus B by A, right? Now, we cannot substitute this. I mean, you can, but then we have to eliminate the value of A. Okay, but so what do we do first? We are going to take this and we are going to substitute in the particular equation. But then we don't have a y dash, right? What we can do is we can substitute in terms of A or in terms of B, something like that. See here, A into y dash is minus B, right? Or you can say that B is equal to minus A into y dash, correct? Now substitute this in terms of B. So if you do that, you'll get, so the first part x by A in the equation, not in this one. So x by A plus y by B is equal to 1. X by A minus y divided by B is what? A into y dash is equal to 1. Correct. Now you can write this as x into y dash minus y is equal to A into y dash. Right? Because A into y dash is the LCM. Fair enough? Now what do we have? See, we need to get rid of A somehow because we don't need that particular value, isn't it? Now, if you take it like this, you have one particular equation, right? Now, A value you won't be able to take it off, isn't it? As in, you can't eliminate A right here, right now. So what do? We differentiate it one more time so that A gets eliminated. But before that, what you can do is you might as well take this equation. Okay, so get it back. X into y dash minus y dash is equal to A, or you can write x minus y divided by y dash is A, right? Now differentiate. You'll get 1, correct? Minus, here you have to apply the quotient rule, y dash square into, so first is y dash into y dash square minus y into y double dash is equal to 0. Take the one that side, or basically you are going to have y dash whole square minus y into y double dash by y dash whole square is equal to 1. So take it on the other side, y dash whole square minus y into y double dash is y dash whole square. Cancel, right? So now what do you get? Y into y double dash is equal to 0, or y double dash is equal to 0. So this is what we are going to get as the differential equation. See, what I showed you is quite a long method of getting the answer. There is a shorter way also, which I'm going to tell you. This is a long method, but it's a very procedural method. So you do this, then this step, then this step, then this step. The procedural way, whatever you're going to follow, that's going to give you this as the answer, right? There is a shorter way, which you can directly get it. Okay, now that you have understood what is the differential equation, now look at this one. You got y dash is equal to minus b by a, correct? That's a value. Differentiate there only. That means after this step it will differentiate. Y double dash is 0. See, here only you get the answer. Don't you think it's one and the same? right? Now, of course, the second method is very short. It's like just three steps. It's very, very simple. But then before you do the shortcut, you need to understand how we get the answer. That's why I did the longer method first, then doing the shortcut method. Clear? So the answer is y double dash is 0. Fine. Let's do the second problem now. See the second one? You have y is equal to this, correct? Differentiate. Y dash is equal to 3a e to the power of 3x minus 2b e power minus 2x. Correct? Again differentiate. Y double dash is 9 into a to the power of 3x plus 4 into b e to the power of minus 2x. Correct? Now, see, some or the other way we need to get rid of that a and b somehow. But y dash and y double dash is of no use for us because you are getting the same thing. But what we can use is we can use the value of y, right? So what do we do? Here you have this one, correct? What you can take is, you can take this as y is equal to, so here let's do that one. Y is equal to a into e power 3x plus b by e to the power of 2x, correct? Now what you can do, you can take the LCM and you can do it. So y is equal to a into e to the power of, see this is going to be e to the power of 5x, correct? E power 5x plus b by e power 2x. Take the e power 2x on that side. So y into e power 2x is equal to a into e power 5x plus b. So what is b now? B is equal to y e power 2x minus a e power 5x. Now we can substitute that value here in the y double dash. Okay. See, why we are doing this is, you can do it here also in both the cases. Because once you apply this in y double dash, I can get the value of a from y dash. Okay, let me repeat it again. We got the value of b from the value of y, correct? Makes sense. You can take that and put it in y dash. Because from y dash, we can get the value of a. Makes sense. So once you get a and b, substitute that in y double dash in the second derivative and you can get the answer. Alright. So first this is b. Let's substitute this in y dash. So what we get when you substitute in y dash is equal to 3a e to the power 3x minus 2b e power minus 2x, correct? Or you can say 2b e power minus 2x is 3a e power 3x. Okay, so y dash also you can keep it here itself, right? So plus y dash. Now substitute for b whatever we have, a to the power of y e power 2x, whatever we have, that we can substitute, correct? So what do you get now? 2 into e power minus 2x, y into e to the power of 2x minus a e power 5x plus y dash is 3a power 3x, correct? This is what we have. Now we're going to take this, we need to simplify this one, all right? Multiply. You're going to get 2y, because e power minus 2x and e power 2x gets cancelled out, minus 2a into e to the power of 3x plus y dash 3a e to the power 3x, right? So take it on the other side. 2y plus y dash is equal to 5a e to the power of 3x, right? What is a? A is equal to 2y plus y dash divided by 5 e to the power of 3x, correct? Now what do? We take this a and b and substitute in y double dash, second derivative. So if you substitute that, you're going to get the differential equation. Okay, so let's do the math. This is what we have, correct? Y double dash is this, A is this, and B is this. But whereas A value we need to substitute here. See, here A value, if you substitute, B value is y e power 2x minus 2y plus y dash into e power 5x by 5 e to the power of 3x, correct? So B is equal to y e power 2x minus 2y plus y dash divided by 5 into e to the power of 2x, correct? You can take e to the power of 2x common and you can simplify it even further. Let's do the simplification part first. Alright, so if you simplify, see this one b is equal to, let me write it here only so that you understand. So b e power 2x into 5y minus 2y, correct? Then minus y dash whole divided by 5, isn't it? So b is equal to e power 2x into 3y minus y dash divided by 5, right? So we are going to take this, substitute in the y double dash and get the differential equation. Fair enough? So let's do the last part of this problem now. If you substitute, y double dash is equal to 9 into 2y plus y dash by 5 e power 3x into e to the power of 3x plus 4 into 3y minus y dash by 5 into e power 2x into e power minus 2x, correct? E power 3x cancels, e power 2x cancels, correct? Now 5 is the LCM in both the sides. We might as well write it as 5 into y double dash is equal to 18y plus 9y dash plus 12y minus 4y dash, correct? So if you take it this way, 5y double dash is equal to 18y plus 12y, correct? So 18 plus 12 is going to give us 30, 30y plus 5y dash, or divide this by 5, you're going to get the answer as y double dash is 6y plus y dash. So this is the differential equation where we have eliminated the arbitrary constants. Fair enough? This is the answer for the second question. Now we are going to move on to the next one, that is the third question. See the third one? Now what you have is y is equal to, directly you differentiate, okay? Because you know what's going to happen with that. So y dash is equal to e power x into a cos x plus b sin x plus e power x into minus a sin x plus b cos x, correct? So y dash is equal to y plus e power x into this, isn't it? Which is a pretty direct way of writing the statement. Directly you can write it. Differentiate again. Okay, so y double dash is equal to y dash plus e power x. So this is the second part, right? So e power x minus a sin x plus b cos x, right? Plus e power x into, this is going to be minus a cos x minus b sin x. Okay, now in this one, isn't it minus y? Because if you take minus common, don't you think that's minus y? So what do you get now? Y double dash is equal to y dash minus y plus e to the power of this one, correct? E power x into minus a sin x plus b cos x. Now what we'll do is, we can use this one. See here, that's nothing but y dash minus y, isn't it? So if you look at this one, That's basically this particular value. So can we write this as y dash minus y? So what do we get now is y double dash is equal to y dash minus y plus y dash minus y. We got it from the previous equation, right? So if you substitute, what do you get? This implies y double dash is equal to 2 times y dash minus y. So this is going to give us the answer to the third question, which is quite direct and easy, I would say. Correct? Now, these are the type of problems where the equation is given to you and you are differentiating and solving it. Correct? Now, in the next set of problems, what you're going to see, you have problems wherein they'll give you a question like find the equation for family of circles, family of parabola, ellipses, like this. So that you're going to see in the next part of these. It's a continuation, but it's more like a part 2 of the next video. All right.